In this video, we'll be finding the area under a sampling distribution curve. This is very similar to finding the area under a normal distribution. And in fact, a sampling distribution will be a normal distribution given we have a large enough sample size. Usually 30 is big enough, 50 definitely does it. That's by the central limit theorem. But just for calculating, let's look at this. Rental rates for a similar sized apartments in a particular city average $900 with a standard deviation of $125. If you take a random sample of 30 apartments, what is the probability that their mean rate would be less than $850? And I really emphasize the word mean because if you see that in a question and it's asking for the mean of something, then the probability that the mean is above or less than or between two numbers, that's when we're going to have to play this game. And all it is this. We're going to use this norm dist function, norm dist, and then you've got x, the value in question. You've got the mean. You've got the standard deviation. But wait, when we're talking about the probability that the mean is above or below or between two numbers, we're going to use the standard deviation, sigma, divided by the square root of the sample size. N is the sample size. And then we'll say true because we always do true with the normal distribution. Now, what does that mean? Just in case you have not used the normal distribution function before, well, Excel is pretty nice about this. You don't have to look this up on tables. You get the mean, and the mean of the means, that is for the sampling distribution, is 900 here. So we've got this mean at 900, and we've got a certain standard deviation, but this standard deviation is actually shrunk by dividing it by the square root of the sample size. But what we're looking for is the probability or the area to the left of 850, less than 850. So that's right here, 850, and we're going to shade that. Now, that looks very big because I already know what the answer is going to be. And actually, the 850 is going to be way down here, and I'll explain that in a little bit. But this is the area, and it's nice to be able to see a very large area just for visual purposes. So to the left of 850, this is what we're finding. And when you type this into Excel, it will give you the area to the left of this x value. So this is our x value. Okay, let me jump over here and just type that in real quick. So equals norm dist. Now, this is Excel 2010 that I've got now, and I'm going to show the function from earlier Excel versions just because the older Excel versions don't have this norm dot dist that you see here. The newer versions do, but the older versions do have the older version, the older function. So I'm going to use the old function just so that everyone can play along. And of course, certainly if you have the new Excel, use this norm.dist, that's fine. It's the same as norm dist without the period in between. So I'm going to type in the old function, norm dist. All of this syntax is exactly the same, whether you use norm dist or norm.dist. Now I'm going to type in x, that's our 850, comma, we have our mean of 900, we have a standard deviation of 125, but wait, it's divided by the square root. That's SQRT in Excel language. SQRT, square root of something, square root of our sample size. That's this, sample size, 30. Okay, so we've just typed in what I have circled in green here. 125 divided by the square root of 30. And then true, that's giving us all of this area to the left of 850. Excel always works with the left area. Okay, we hit enter, and there we have it. There's our answer, 0.0143. Now that's why I said earlier that I've drawn this very big. This area should not be drawn this big for that small probability because this is 0.014 is this area. So the answer, the probability that the mean, notice I'm going to put x bar, probability that the mean is less than 850, equals 0.014. Okay, that's our answer. Now, why is it so much smaller? If we did just the standard deviation here, just the 125, we would get a much larger number for this area. Well, the reason is because when you take a sampling distribution, you are making this standard deviation a lot smaller when you take a sampling distribution, because you're taking a sample of size 30 in this case, and so the average of all of these different samples that you're taking, imagine a population of 400,000 apartments. That's a lot. Well, that's quite a few many different samples you could take of size 30. So most of their means, most of those sample means, will get close to the population mean. So what happens is this actually shrinks, this curve. It's still centered around the mean. So what I have drawn in blue now is really closer to the sampling distribution of means. But the important thing is, and I should show this real quick then, if we did the 850, here we'd have this area, which is a little bit smaller than what we had in red. But the important thing, the really important thing that I wanted to emphasize, even if you don't understand all of what I said at the end here, I hope you do, but even if you don't, the really important thing is that you understand this part. This is, if they're asking for what is the probability that the mean of some sample is above or below or between, you use this standard deviation divided by the square root of the sample size. All right, I hope that helps.